Hello champion, I'm teacher Adam. Welcome to my math class. I'm going to review the speed time graph, and actually we have done in our previous class, but today I'm going to show you how different definitions and why majority of the students who are doing Igcse math or Igcse physics, they always fail these kind of questions, especially when the terminologies become very closely related. It might mean the same thing if you're not careful. One thing about it, we are talking about it's the unit of kinematic. Obviously, in my previous math class, I taught you about kinematics. To say kinematics is the study of objects that are moving from one point to a particular point. And actually, we looked at different scenarios. We say objects can move from point A to point B within a specific time, and maybe they might even change speed. So there is that changing in speed in the same unit of kinematic, whereby you'll meet a term called acceleration. We said acceleration is the rate at which. So we want to, first of all, what is kinematic? What is kinematics? So in our previous math class, we said kinematics is the study of objects in motion. So this object in motion can either have constant speed or change speed. So when they change speed, that becomes acceleration. When they reduce speed, that becomes deceleration. So you have to understand this term. And then so we said, on our kinematic graphs, we say speed is always shown on the y-axis and time is always given on the x-axis. So whenever you have a graph like this one on a kinematic graph, this y-axis, the vertical line, is always the y-axis, and the horizontal line is always called the x-axis. And here, this is origin point. So in kinematic, we know the speed will always be here. It can be meters per second or kilometer per hour or miles per hour. How do you know? So it can be within that time frame. And then here time, if you're given in meters per second, this will be second, time in seconds. So this is always time. That's speed. Speed is always shown on the y-axis. And then you say speed is on the vertical axis, time is on the horizontal axis. And when we say acceleration, what did we say acceleration is? Acceleration is equal to change in speed. So we know it's speed divided by time. But here, change in speed. So here it's change in speed divided by time taken for the speed to change. And this is always represented by rise over run. We have talked about that. So we say whenever you have a positive gradient, they say also a positive gradient shows positive acceleration. So a positive gradient shows a positive acceleration, like the car is going. So obviously, for a car that is accelerating, you will not have a straight line. You will have a curve like that one. So this shows acceleration. You can see a point here and maybe a point here. And then we say if you're having a curve like this one, maybe from point A to point B, and then you say a positive gradient shows a positive acceleration speeding up. A negative gradient shows negative acceleration slowing down. This is also called deceleration. So for example, this one is, you cannot say, you say this car is accelerating because the speed here and speed at B, they are quite different. And then we say you have the same graph, x-axis and y-axis, and then you have something like this. This is deceleration. This represents deceleration. Okay, you can see if you are talking about this point here and a point here, you can see it's a negative gradient. Whenever it's a negative gradient, it is deceleration. Wow, that's good. You can have some scenarios, maybe you're told to find maybe for how long was the car traveling at a constant speed. So understanding constant speed, we say a constant speed is shown by a horizontal line. When you have your curve like this y-axis, in this unit we'll draw a lot. Sketching, x-axis. So here I have my sketch, and then you have maybe to that speed, maybe you have this is speed and this is time. Then you have that, and then yeah, you have this car. They say for how long was the car traveling at a constant speed? A constant speed will be shown by a flat line. This is a point, because maybe let's say this is 2, 4, 6, 8, 10, 12, and then this is time, maybe 5, 10, 15, 20. Time in seconds. So you see here, from when the time was at 5 seconds to when the time is 15, the car did not change any speed. The speed was still the same. The speed was 8 meters per second. So they say, for how long was the car traveling at a constant speed? With that one, you are able to interpret. And then calculate the acceleration during the first 6 seconds. Calculate the acceleration during the first 5 seconds. Acceleration means the rate at which speed is changing per given time. So from this point at origin, 0, 0, to when it was 0, now it's at 8, but it has changed under what time? Under 5 seconds. It used 5 seconds. So acceleration is equal to rise over run. Speed divided by time. So our speed is 8 divided by time. So, wow, acceleration is equal to rise over run, which is speed divided by time. Now, our speed here is 8 meters per second. Our time here is 5 seconds. And then you get our answers, 8 over 5 meters per square seconds. Acceleration is always shown in squared units. Wow, that's what you get. And if you are asked, calculate the total distance traveled. The total distance traveled from, so the total distance is equal to the area. Is equal to the area. So here you can have area of A, B, and C, or 1, 2, 3. This is a triangle, this is a triangle, this is a rectangle. That's it. Find the area. It should be equal to the total distance traveled. So in that case, you say area a half times base, which is 5 seconds, times the height, which is 8 meters per second, plus the area of this one, 15 minus 5 is 10 times 8. Then plus a half times the base, which is 5, times the height, 8. If you do this, you add together, you get the total area, which is equivalent to the total distance traveled by this object. In that case, you'll have here 4, then that's 20 meters plus 80 meters plus plus 20 meters. That means your answer is 120 meters. So the car covered 120 meters. And then that's it. So you might have different kind of questions and understand, you'll be able to solve. You're given a question, then they say, maybe find the deceleration of the car between 10 and 13 seconds. It's easy when you're given a question like that, because if you're finding the deceleration, just understand what is your maximum speed. Maybe it was 8 meters per second, and then they say find the deceleration between 10 and 13. It's simple. Maybe you have a graph like this one, y axis, and you have x axis. Then you have time in seconds, and then you have graph here. They show speed. Then you have boom. You have that. So we have speed in meters per second, and then we have this figure. Then say the diagram shows the speed time graph of part of a car journey. Find the deceleration of the car between 10 and 13 seconds. So this time in seconds. This maximum speed is 8. So we have 8 meters. So our maximum speed is 8. So we have 8 meters. That's our maximum speed. Our maximum speed is 8 meters per second. And then the time taken, we need to know now. Time taken is 13 minus 10, which is 3 seconds. 13 minus 10, which is 3 seconds. So we need to find the deceleration. Deceleration, you just say 8 divided by 3. Meters per squared second. 8 over 3 meters per squared second. That's the answer. As simple as it is, you get your actual answer. And then if they say the total distance covered, is simple. Find the area of this shape, A and B. This is a rectangle, which is 8 times 10. So we find total distance is 8 times 10 meters. In total, it's 80 meters. And then find the area of this one, a half times 3 times 8, which is 12. So 80 meters plus 12 is 92 meters. That's the total distance covered by this car. Wow, and 92 meters. These are the kind of questions you will experience in this unit. See you at the top champion. I can't wait to see you succeeding well. Bye bye until we meet again in our next math class.